Chapter 1: Lost Laws of the Colossus. Imagine standing on a sandy beach, looking up at a giant bronze statue that gleams impossibly bright under the Mediterranean sun. It's taller than a 10-story building and seems to touch the sky. This is the Colossus of Rhodes, one of the 7 wonders of the ancient world. For over 50 years, this statue stood proudly in the harbor of the island of Rhodes. But how did ancient builders create such a marvel? And could it be that they knew things about physics that we've somehow let slip through the pages of time? The Colossus was built around 280 BC to celebrate Rhodes' victory over a siege. Crafted by the sculptor chairs of Lindos, it was more than a mere statue. It was a symbol of unity and strength. Standing about 33 meters tall, or around 108 feet, it was said to be as tall as the modern Statue of Liberty from foot to crown. Can you imagine something so grand, constructed so long ago, without modern tools or technology? This leads to a big question about the knowledge applied in its creation. The construction required not just artistic skill, but advanced engineering. Bronze plates covered an iron framework, a feat demanding a sophisticated understanding of materials. The ancients knew that while bronze corrodes, it forms a protective patina that preserves the metal beneath, a natural wonder they harnessed. This foresight in material choice shows us that their grasp of chemistry, though not named as such, was incredibly intuitive. Furthermore, how did they manage the actual construction? It's believed that earthen ramps and pulleys were used, which points to a keen understanding of physics and mechanics. Moving massive stones and materials with precision needed teamwork and a deep knowledge of balance and force distribution. Did they pass around scrolls titled Physics 101? No, but somehow they devised solutions to monumental problems that architects and engineers find daunting even today. A deeper dive into similar ancient feats, like the deadly accurate placement of stones in the Great Pyramid of Giza, or the curved reliefs on Mayan structures, suggests these builders might have possessed scientific intuitions we've only rediscovered in modern times. Some experts suggest that the builders had extensive experience with trial and error over generations. They understood, perhaps through observation and oral tradition, principles we now describe with equations and textbooks. Interestingly, ancient Roman architect Vitruvius wrote about such marvels and principles in his treatises, emphasizing harmony, strength, and beauty, perhaps hinting at a methodology lost over centuries. His work became crucial during the Renaissance, a time when many ancient texts were rediscovered and studied anew. Greek philosopher Archimedes, a near contemporary of the Colossus, might also have played a role indirectly by influencing others with his studies of buoyancy, levers, and catapults. Imagine if Archimedes or his disciples exchanged ideas with builders, seeding early concepts of mechanics into the project. Their legacies show that the ancient grasp of scientific principles was profound and practical. They saw physics not as abstract notions, but as daily tools. Every time an ancient structure puzzles modern scientists, there's a sense of admiration mixed with mystery. Consider modern investigations using technology like ground-penetrating radar and 3D modeling to study ancient sites. They unravel secrets without disturbing the historical integrity. These methods reveal astonishing insights: the precision of stone placements, construction, logistics, and even the climate at the time of building. These details help us appreciate just how advanced, in some respects, their understanding could have been. Could we ever achieve such mastery again, given today's reliance on technology? The ancient builders didn't have computers, yet they crafted marvels. They relied on a blend of observation, shared knowledge, and perhaps a profound respect for nature's principles, which might be the biggest lesson of all. Approach nature with respect and curiosity, and you gain a partner in innovation. In light of all this, new questions abound. If we consider how ancient builders utilized specific geographic points, star alignments, and material combinations with what seems to be deliberate purpose, what might they teach us about sustainability and resilience today? Are there techniques and insights we could reclaim to solve modern engineering challenges? As fascinating as these questions are, they remind us to cherish and investigate our human heritage. Ancient achievements like the Colossus not only showcase lost skills, but also urge us to reflect on how much more our ancestors knew intuitively. It makes one wonder if we've been standing on the shoulders of geniuses, without fully comprehending the heights they reached and the laws they might have understood in their time. By continuing to learn from these ancient innovations, we may uncover solutions that benefit our world today and enhance our understanding of both past and future. Chapter 2. Stones that float. Imagine wandering through a vast stone city, where every block towers above, smooth and solid. But here's the catch. These stones are so enormous that you can't help but wonder how they were moved into place. Some people have puzzled over this for a long time, wondering if ancient builders had knowledge of physics that allowed them to move these heavy stones with ease, almost like making them float. Throughout history, people have marveled at the great stone structures left by ancient civilizations. The pyramids of Egypt, the mysterious Stonehenge in the UK, and the temples in Peru are a few examples where we've seen remarkable stonework. The big question is, how did they do it? Many ancient structures feature massive stones that, even today, would challenge our construction abilities. So, what if these builders had a special understanding of physics that we can't quite grasp today? One theory always comes up. Acoustics. Sound, in the form of vibration, is a powerful force. If you've ever been at a concert, you've felt the power of sound waves in the way they thump in your chest. The idea here is that ancient builders might have used sound waves to move or even lift heavy stones. This might sound like something out of a science fiction novel, yet there's a fascinating experiment that relates to this. In the late 20th century, a fascinating study showed that certain frequencies of sound waves could create patterns in fine particles like sand or salt. Scientists found that sound can indeed influence objects, making them float or rearrange themselves in specific formations. This is known as cymatics. Now, imagine if ancient people knew how to harness these properties to aid construction. It's a thrilling thought. There are also stories and legends passed down through the ages that hint at such possibilities. Some tales from indigenous peoples speak of priests or leaders who would chant and create sounds that could lift heavy stones. These accounts, though often dismissed as mere myths, gain new intrigue when paired with modern studies showing sound's potential effects. But what about other methods? Another approach suggests that knowledge of air pressure and buoyancy played a role. Some researchers have speculated that ancient builders might have understood how to trap air under massive stones, making them lighter and easier to move across water or even land. Think of lifting a large object while underwater. It becomes much easier than trying to lift it on dry ground. Despite the fascination surrounding these ideas, it's vital to note that no definitive evidence exists yet to prove that such methods were used. Science operates on evidence, and without concrete findings, much of this remains speculative. Still, it's the lack of evidence that often drives researchers to look deeper. Consider the unexplained use of liquid mercury under the pyramids and temples in Mesoamerica. Mercury is a heavy, shiny metal that flows like water. While its exact purpose in these ancient sites remains uncertain, some have theorized it might be related to such complex physical processes. Modern-day scientists are intrigued by what these ancient societies could have known about mercury that would lead them to employ it for architectural purposes. It's also interesting to consider the geography and geology that these ancient builders had to navigate. They often chose locations with unique geological properties, possibly knowing how to exploit them strategically. For example, the pyramids in Egypt stand on a plateau that's rich with minerals that could have aided construction in mysterious ways still to be fully understood. Looking at these ancient wonders with a modern scientific lens, we realize there is much more to learn. Perhaps these ancient civilizations, through trial, error, and keen observation, uncovered some tricks of nature that we are only now beginning to appreciate fully. They achieved what they did without computers or modern machinery, which remains an inspiring mystery, calling experts and enthusiasts alike to investigate further as we continue to uncover clues about how ancient builders accomplished their impressive feats. We gain not just knowledge about the past, but insight into the incredible potential of human innovation. We are urged to think about the hidden laws of nature we might still uncover. This exploration lets us connect with the innovative spirit of our ancestors, who, with the simplest tools, challenged the limits of what's possible and constructed monuments that continue to amaze and inspire humanity. In the end, these ancient architectural achievements serve as a testament to human creativity and mastery of the natural world. Regardless of whether their techniques involved forgotten principles of physics or simply ingenious methods lost to time, whether by sound, geometry, buoyancy, or something else entirely, the quest to understand continues, ensuring that the age-old wonder and curiosity remain as stone-solid as the structures themselves. Chapter 3: Harmonies of Architecture. Imagine standing in front of a towering stone structure that has weathered centuries, maybe thousands of years, with its grandeur still intact. Here lies a world built by hands that understood not just the art of construction, but perhaps the very science of the universe in ways we might not fully grasp today. This world is ancient architecture, filled with the secrets of builders, who might have known more about physics and harmony than we often give them credit for. Let's take a moment to travel back to ancient Egypt, where the pyramids loom large on the horizon. These massive structures, like the Great Pyramid of Giza, were crafted with such precision that even today, scientists marvel at their exact alignments and measurements. Some researchers suggest that the builders had an understanding of geometry and mathematics that allowed them to align the pyramids with the cardinal points of the compass. There are theories indicating they might have understood the concept of pi, using it long before it was formally discovered. Now, consider the acoustics inside these grand structures. Studies have shown that certain chambers within the pyramids resonate at particular frequencies. Some researchers claim that this was not merely a coincidence, but a deliberate design, allowing for sound to travel in specific ways that could have been used in ancient rituals or ceremonies. These sound harmonics might have had a specific significance or purpose, perhaps even believed to connect with the divine or other natural forces. Moving on to the ancient city of Teotihuacan in Mexico, we encounter another impressive example of construction. The builders of this city seemed to have understood something profound about the physics of sound as well. At the Temple of the Feathered Serpent, a peculiar acoustic phenomenon occurs. A clap in front of the temple produces an echo that sounds remarkably like the call of the Quetzal, a bird sacred to the people of that time. Did they discover this effect accidentally, or was it part of their architectural intention? The precise reason remains a mystery, but it shows an impressive control of sound. In Greece, the ancient Greeks constructed theaters with amazing acoustics, where actors on stage could be heard clearly by audiences tens of meters away. The design of these theaters, with their curved rows and specific angles, played with the world of sound waves in a purposeful manner. Theaters, like Epidaurus, are scientific marvels, demonstrating that the ancients were fully aware of how to manipulate sound with site-specific constructions. Let's not forget the iconic Stonehenge. Encircling this structure, experts suggest, is an unintended soundscape. Researchers using acoustic technology discovered that the positioning of these stones might have been carefully planned to enhance certain sound frequencies, leading to the hypothesis that ancient ceremonies could have been enhanced by this natural musical performance provided by the stones themselves. A particularly fascinating example comes from the Inca civilization in Peru, where builders crafted walls with stones fitting so snugly together that not even a blade of grass can pass between them. These structures were also highly resistant to earthquakes, an incredible feat considering the seismic nature of the region. Some believe this precision and durability were the result of understanding seismic forces and creating harmony between the stone structures and the Earth's natural movements. The Roman aqueduct, a symbol of ancient engineering prowess, utilized the concept of gravity and gradient to deliver water across vast distances, demonstrating an understanding of the natural forces at play. The Romans, it seems, exploited principles of the natural world with meticulous planning and execution. These architectural wonders invite us to think about the knowledge these builders possessed, a knowledge that might have combined scientific insight with intuitive understanding. How did they gather this knowledge? Was it through years of observation, trial and error, or perhaps a cultural heritage of accumulated wisdom passed down through generations? Throughout history, the dialogue between architecture and physics hints at a deep understanding of natural laws. This knowledge might have been different from today's scientific understanding, enriched perhaps by ancient techniques and perspectives that we no longer practice or even comprehend. Can our modern approach to architecture learn from these ancient marvels? Could we explore the possibilities of harmonizing construction with natural forces, employing the wisdom of the ancients to our contemporary world? What remains certain is the lasting legacy these structures provide, standing reminders of the incredible feats of engineering humans have achieved long ago. Exploring these ancient structures incites the imagination. We are spurred to ask ever more questions. What other secrets lie hidden in these ancient techniques? Might there be more to learn if we look under the surface? The world of ancient architecture beckons, a historical whisper urging us to continue the journey of discovery. Chapter 4: Secrets of the Silent Cities. Imagine wandering through a place where towering stone structures rise silently all around you, their histories carved not only in stone but also hidden within the mysteries of time. Many places on our planet hold ancient wonders, but few are as puzzling as some of the great cities left behind by the ancients. As we explore these silent cities, we ask ourselves, did their builders know something we don't know now? Let's start with a rather intriguing place, the massive and mysterious Stonehenge in England. Here, enormous stones, some weighing over 25 tons, were somehow transported over long distances and arranged into a circular formation. But how did they manage it? Some stones were moved from as far away as 150 miles without the aid of modern machinery. While the exact methods remain unknown, researchers suggest they might have used wooden sleds and rolling logs, turning this monumental task into something achievable with sheer human determination. Perhaps ropes and counterweights helped, showcasing a primal understanding of physics that leveraged the tools available at their time. Math and cohesion became their roots, and muscle, ingenuity, and a little bit of mystery did the rest. Next, we'll take a journey to the warm and vibrant lands of Mexico, to the city of Teotihuacan. This city is truly ancient, built over 2,000 years ago. It sprawls out in a complex grid pattern, complete with wide avenues and massive pyramids that seem to touch the sky. The Pyramid of the Sun, one of the largest structures there, invites us to ponder its existence. Some researchers suggest that its builders used a keen understanding of geometry and solar alignments to reach such perfection. Every year, on precise dates, the sun aligns in ways that are simply breathtaking. This carefully crafted relationship with the heavens may indicate a deep understanding of both the celestial bodies and the principles of construction, what we might call an early comprehension of astronomical physics. Crossing an ocean, we find ourselves standing in awe before the pyramids of Giza in Egypt. These monumental structures have raised questions for centuries. Built with uncanny precision, the Great Pyramid is particularly amazing. Its sides align almost perfectly with the cardinal points of the compass. Recent studies suggest that the builders used something called a circumpolar star to orient the incredible platforms. This alignment hints at an understanding of the Earth's axial precessional wobble in the planet's rotation. This discovery could be pointing us toward forgotten knowledge about the Earth's motion that was somehow woven into their architectural plans. How about the ancient city of Petra in Jordan? Carved directly into the rose-red cliffs, the facades seem to shimmer in the changing light. As you venture through its quiet streets, the innovative water system devised by its creators becomes particularly apparent. Ingeniously designed channels and reservoirs collected and stored rain to manage both supply and overflow, a feat of complex civil engineering. The Nabateans, builders of Petra, demonstrate a sophisticated grasp on the flow of both water and energy, what we might see as elementary hydrodynamics. Their solutions to the taxing environment around them continue to impress scholars and engineers today. Then there is the mysterious city of Machu Picchu in Peru. Situated high in the Andes Mountains, it astounds not just for its beauty, but for the astounding terracing and draining system that has kept it secure for centuries. The rocks fit together so tightly that not even a piece of paper can slide between them. This reveals an understanding of seismology. The city's stones can move slightly, allowing them to withstand earth tremors without toppling. Was this an intuitive genius for construction, informed by observing nature? Perhaps so, but it tantalizes us with questions about knowledge lost to time. While we wander through these incredible remnants of ancient times, we are faced with clues that these ancient civilizations possessed a varied knowledge of natural phenomena and mechanics that may be surprising for their time. This knowledge, integrated into their architecture, reflects a deeply interconnected understanding of the world around them, one that we are only beginning to appreciate. Finally, whether it be the unerring stone alignments of Newgrange in Ireland with a solstice sunrise, or the mysterious geoglyphs of Nazca that stretch out across the Peruvian desert floor, each location leaves behind whispers of what once was. In them is hidden not just the stories of a people and their crafts, but also a reminder to us. Perhaps, as we dig through time with modern tools and theories, we uncover more than just stones and bricks. We uncover glimpses of truths and physics once known, perhaps sleeping silently within their silent cities, waiting to be rediscovered. could there reside within those stones? A wisdom still waiting for us to fully understand. Such questions and the longing to answer them are why the exploration never ceases. Chapter 5: Gravity's Forgotten Dance. Imagine walking through a world before electronic screens and carbon footprints, long before our modern gadgets took over. Picture a vast world where sharp minds and calloused hands shaped towering structures with nothing more than basic tools and an eye for precision. It's a different time, and knowledge is kept safe through stories and the passing of experience from one generation to the next. Here, nature holds many secrets, and one of its most remarkable forces is gravity. Gravity is something everyone knows and feels every day. It's the pull that keeps us grounded, literally. But what if, long ago, some builders understood gravity in a way we have since overlooked? Let's step back into history, with the slippers of curiosity on our feet, and explore how the ancient builders might have interacted with this ever-present force of nature in a very special dance. When we think about extraordinary ancient structures like the pyramids of Egypt, Stonehenge in England, or the aqueducts of the Romans, we marvel at their size, precision, and endurance. Have you ever wondered how these immense stone structures were put together with such precision and skill? How did people without cranes or engineering degrees move stones weighing several tons, fitting them together so closely that even a sheet of paper can't slip through? In considering these questions, it helps to think about how these ancient societies might have observed gravity, not just as a force but perhaps as an ally in their grand designs. Different cultures around the world developed their own techniques, very likely honed by careful watching and testing over many generations. Take the Great Pyramid of Giza. These immense structures didn't just pop up magically. Some fascinating studies have suggested that ancient Egyptians may have used ramps, lever-like tools, and even possibly wet sand to effortlessly slide massive stones into place. Experiments conducted by physicists and engineers today have recreated these methods to some success, suggesting they might not be just myths. Imagine using gravity itself to help nudge these giant blocks across the Earth quicker than we might think possible. Further north in Europe, Stonehenge stands in silent mystery. Scientists and historians alike have marveled at how massive stones were moved over 140 miles from their origin. Some studies proposed the clever use of wooden tracks or ball bearings carved from timber might have spread the stone's weight, allowing them to be rolled overland. Could groups of people, knowledgeable about the balance and weight distribution, have worked in perfect harmony with nature's laws? Some think they essentially commandeered gravity to aid in their ambitious visions. And yet, across the world, in places like Machu Picchu in Peru, we see how ancient Incas carved and transported impossible amounts of stone through mountainous terrains. How did they manage it without modern logistics? Many experts believe that understanding the balance of the stone's weight and the natural landscape was key. They might have used specific angles and force application to exert control, keeping gravity's alluring tug on their side. Scientific understanding continues to unfold around these timeless structures with each passing day. A recent physics-based study created models showing that using specific inclines and methods of tension and compression could have reduced the effort required to pull heavy items greatly, essentially borrowing gravity's assistance for these spectacular feats. The ancient builders' relationship with gravity doesn't just show in how the stones were moved. It's also in how these structures stand today, strong and proud despite being hundreds, if not thousands, of years old. Modern architects and engineers still study these designs. They have found surprising techniques, such as the way pyramid stone blocks interlock so closely that they offer remarkable resistance to earthquakes. A natural disaster that exercises gravity's might in destructive ways. While modern computations and technologies have developed more sophisticated methods for building, we must not dismiss the wisdom of these early innovators. Their secret, perhaps, was not in sophisticated machinery, but in an intimate understanding and respect for the natural world, gravity included. This brings us to the wider thought. Are there other aspects of nature's forces, like gravity, that ancient cultures might have mastered in ways now forgotten? What can we learn by stepping back into these ancient landscapes with modern science in hand, ready to translate old knowledge into new understanding? The flow of knowledge through history is like a dance, moving in steps that are sometimes slow, sometimes quick. Today, we have the chance to look back and learn from these master builders who, with their profound yet simple understanding, shaped the world. There's a sense of awe in realizing that, aided by gravity, humans have always strived to reach the skies. It's a conversation between humanity and the universe, where, if we listen closely, we might just rediscover timeless truths. Chapter 6. Echoes of Empirical Engineering. Imagine, for a moment, you are standing amidst the grandeur of ancient structures, feeling the whisper of their creators and experiencing a world where physics was a language as familiar as the one we speak. Throughout history, civilizations across the globe erected breathtaking monuments whose precision and durability have sparked endless fascination. These structures aren't mere random wonders. They are whispers from the past, echoes of a sophisticated understanding of the world around us. Let's take a closer look at what we know and, perhaps, what we have yet to discover out how ancient builders viewed their robust structures and the natural laws that guided their creation. The pyramids of Egypt serve as a perfect starting point, not only because they are iconic, but because they embody an enigmatic mastery of engineering. Constructed over 4,500 years ago, these stone giants reveal an ample comprehension of fundamental principles such as weight, distribution, and geometric precision. It's tempting to view them as simple stacks of stone blocks, but their architectural accuracy defies that simplistic notion. The Great Pyramid of Giza, for example, was built with such precision that each side is aligned almost perfectly with the cardinal points of the compass. This perfection suggests more than a mere understanding of geography. It hints at a sophisticated grasp of mathematics and observational astronomy. Moreover, recent examinations by archaeologists and engineers propose that the builders exploited the properties of different stones for varied purposes, selecting specific types to withstand the heaviest weights or to ensure durability. This careful selection shows a deep empirical understanding of materials, something akin to what we today consider material science. Beyond Egypt, one can witness the marvels of ancient ingenuity in structures like Stonehenge. Often shrouded in mystery, Stonehenge stands as a testament to ancient astronomical knowledge. Scholars now believe that it was designed to act as a calendar or observatory aligned with solar and lunar events. The placement of stones captures sunrise on the summer solstice and is aligned with the movements of the moon, reflecting a studied awareness of cyclic celestial patterns. This suggests that the creators posited theories based on prolonged observation and experimentation, a kind of empirical methodology that prefigures modern scientific approaches. Similar insights emerge from the varied architecture of ancient Greece and Rome, where builders and philosophers combined engineering with philosophy and abstract thought. Vitruvius, a prominent Roman author and architect, captured this interrelationship in his work De Architectura, where he outlined guidelines that combined aesthetics, functionality, and harmony principles many modern architects still study. He expressed the idea of architecture as a science, not just an art form, demonstrating an awareness beyond simple construction techniques and touching on principles like acoustics and mechanics. Considering these examples, one must ask, could it be that ancient civilizations viewed their world through a lens of practical physics, derived from years of observation and experiment? This wouldn't be physics in the highly theoretical sense we know today, but rather a form of empirical engineering. Knowledge wasn't amassed in textbooks, but passed down through generations, embodied in stone and wood. This raises another intriguing thought. Have we lost or forgotten certain empirical insights these builders might have known, insights that were both practical and profound? While we explore these questions, it's crucial to consider evidence rather than conjecture. For instance, in the field of acoustics, we find civilizations like the Maya harnessing sound waves in unique ways. Structures such as the pyramids in the ancient city of Chichen Itza reveal acoustic phenomena believed to be deliberately engineered. Clapping in front of the pyramids produces an echo that mimics the chirp of the sacred Quetzal bird. Was this an intentional design of sound reflection and resonance, or a serendipitous accident? The prevailing theory leans towards the former, suggesting calculated design, from bridges and roads of ancient Rome to the aqueducts of Persia. These builders left behind a legacy where empirical knowledge was a precious tool in handling the forces of nature. Bridges stood the test of time, arches were crafted to maximize strength, and roads unwound through treacherous terrains to connect vast empires. Modern investigations often discover materials like Roman concrete, which remains inexplicably resilient after centuries under the harsh sea, hinting at a recipe modern science has yet to decode fully. These echoes challenge us to reconsider our narrative of technological progress. We often view history as a straightforward journey from ignorance to knowledge. Yet the sophistication of ancient engineering suggests the existence of wisdom lines not quite aligned with this narrative. What if some of the knowledge they applied was subtly forgotten along the way, overshadowed by leaps in other scientific arenas? What if our ancestors understood certain interactions of forces, materials, and structures through repeated trial and error in ways that our reliance on theoretical models sometimes overlooks? Reflecting on these ancient practices prompts us to imagine how rediscovering or reinterpreting some of these forgotten empirical methods might serve us today. In times where sustainability and resilience are paramount concerns, could the durability and efficiency of these constructions offer lessons for modern engineering challenges? The idea isn't merely academic. It's about adapting lessons learned from inherited wisdom to current environmental and structural demands. While we seek answers, perhaps the pursuit of understanding could be as valuable as the answers themselves. By striving to see the natural world as these builders did, through a hands-on relationship with the physical and metaphysical, we open up a dialogue between the past and present, an exploration that might not yield all the secrets we seek but will surely enrich our appreciation of human ingenuity and its timeless quest for knowledge. Chapter 7. The Marble Mystique. Imagine, if you will, a time thousands of years ago when ancient builders stood on the banks of the Nile, observing the massive pyramids they were creating with awe-inspiring precision. How did they achieve such breathtaking feats? While the scale and the grandeur of these structures often steal the spotlight, it's the hidden details, the seemingly insignificant choices like the use of marble that whisper clues about the builder's understanding of physics that today feels both familiar and mysterious. Marble, in the world of stones, is like a refined delicacy. It's not just beautiful, It's firm and easy to work with, resisting time's harsh touch like few other materials. Many grand monuments, from pristine Roman sculptures to the elegant Greek temples, owe their aesthetic longevity to this remarkable stone. What if the choice to use marble was more than just an artistic or practical decision? What if these ancient builders knew something more about its properties? Perhaps they understood that marble, with its unique qualities, could play a role beyond just looking pretty. To dive deeper, let's start with the basics. Marble is a metamorphic rock, which means it's formed from other rocks that have been transformed by high pressure and heat over millions of years. This natural stone is primarily composed of calcite, a crystal form of calcium carbonate. When light hits a piece of marble, some of it travels through the surface, giving the stone its characteristic glow-in effect called translucency. This property has long been used to enhance the play of light in buildings and sculptures, but did it fulfill more than just an aesthetic function in ancient structures? Consider this. Natural sunlight is a source of not only light, but also warmth. By skillfully positioning marble structures or using thin marble slates, ancient builders may have been able to control how much warmth entered a building. This kind of passive solar heating would allow for natural temperature regulation, a concept that we're still refining in modern architecture with our focus on green building technologies. The Egyptians might not have left behind handbooks filled with equations and theories, but their monuments suggest an experimental knowledge deepened by keen observation and record-keeping. Recent studies indicate that the use of marble or similar stones possibly influenced buildings' acoustics as well. The Parthenon, for instance, isn't just renowned for its grandeur, but also its impressive acoustical properties. The very layout and choice of materials like marble may have helped manage sound waves, guiding them in ways that enhanced clarity inside these massive spaces. This understanding isn't too far removed from what audio engineers strive for today when designing concert halls and auditoriums. The Romans took it a step further. They built intricate baths and villas that could keep in heat despite the winter chill, sometimes even installing underfloor heating systems known as hypocausts. Marble, with its ability to retain substantial thermal energy when warmed, was a natural choice of material, which undoubtedly aided in the efficient running of these heating systems. This suspected knowledge of thermal mass properties, whereby they selected certain stones that absorbed, stored, and released heat energy, hints at a sophisticated comprehension of passive temperature regulation on a grand scale. But why had they developed such a nuanced understanding of these materials? The simple answer could be necessity, the mother of invention. When confronted with the limitations of their time, like lacking plastics and modern insulation materials, they turned to their surroundings, studying nature's own options meticulously. Through careful experimentation and observations over generations, they developed methods to harness the subtle properties of materials like marble and others to suit their needs. Today, as researchers slice through marble samples from ancient sites, they often find it doesn't possess just a uniformity, but a layered complexity. Studies using modern technology like scanning electron microscopes and geochemical analysis allow scientists to explore these stones in great detail, revealing secrets locked in their crystalline structures. Through these methods, we've started to discern intentionality, where once there might have seemed haphazard placement. More interesting still is the interplay of water with marble and other stone choices. The ancients constructed structures that dealt remarkably well with water flow and retention. Marble fountains, for instance, were designed not just for grandeur, but for the physics of water pressure and motion. These features could serve multiple purposes, from cooling the air in the surrounding areas to irrigating nearby lands. Could it be that ancient cultures were capable of understanding these advanced principles simply through observation and practice, without formalized scientific knowledge? When considering how they've managed to create such lasting icons of human achievement, it's clear they must have carefully studied everything about their materials' subtleties of weight, color, texture, and how they interacted with sunlight and time. Their legacy invites us to consider how advancements often come not only from discovering new materials, but from advancing our understanding of how to use the ones we already have. Hidden within their choices lay insights into energy transfers, structural soundness, and the very interaction of materials with natural elements. Looking back at them, could it be that there is still much we might relearn from our ancestors? The story of these ancient peoples might not be fully written in books, but their buildings surely sing a song of ingenuity, giving us a peep into a world where every choice held the weight of both beauty and science. Instead of seeing them as merely primitive, perhaps it's time to view them as partners in a long, unfolding conversation about how we shape the world and how, in return, it shapes us back. Chapter 8. Hidden Forces of the Pyramids. Imagine standing in the vast Egyptian desert, the hot sun beating down as it has for thousands of years, and before you loom the colossal pyramids of Giza. These ancient structures have fascinated people for centuries, not just because of their size and grandeur, but because of the mystery surrounding their creation. How did people living so long ago manage to build such remarkable structures? And, as some wonder, could they have understood the principles of physics in ways that are lost to us today? Let's start with the Great Pyramid of Giza, the tallest man-made structure in the world for over 3,800 years. Many have marveled at its perfect alignment with the cardinal points north, south, east, and west, suggesting an understanding of the Earth's geography. Some researchers propose that ancient builders used the stars to achieve this impressive alignment. In particular, the Great Pyramid was aligned with the North Star, which, due to the gradual wobble in the Earth's rotation, was not the same as the one we know today. The precise knowledge required to build such alignments raises questions about the observational skills and methods available to these ancient societies. Could they have used complex mathematical calculations long before they were documented in history? Another point of intrigue is the construction of the pyramid itself. Each block weighs several tons, and there are over 2 million of them. The transportation and assembly of these blocks would require not just physical strength, but a deep understanding of mechanics. Some have suggested the use of wooden sledges sliding on lubricated tracks of Nile mud. This method would drastically reduce friction and make moving these giant blocks possible. Recent experiments have shown this to be a practical solution, demonstrating that a small team could indeed move a large stone with relative ease, illustrating a clever application of physics principles like friction and force. Let's look at the acoustic properties of the pyramids. Inside some chambers, you will find unique sound behavior. Certain frequencies resonate particularly well, leading some to suspect these rooms were designed with sound in mind. In 1997, an acoustical engineer conducted studies within the Great Pyramid, analyzing how sound waves behaved in its chambers. He found that these structures might amplify sound in particular ways, a result that intrigues archaeologists and physicists alike. If these characteristics were intentional, what purpose could they have served? Were they merely a byproduct of the construction techniques, or something more? Some theorists suggest they might have been used for ceremonial purposes, with the resonance creating an immersive auditory experience. Water also plays a captivating role in the exploration of pyramids. A small number of scientists suggest that ancient builders might have used water in their construction process. For instance, it has been proposed that canals connected the Nile to the pyramids specifically for transporting materials. An even more intriguing idea is that these ancient civilizations might have harnessed water power more directly. Some researchers theorize that geysers or natural aquifers could have been used to lift the stones. Although this remains a debated topic, it's another testament to the innovative possibilities considered by ancient minds. The pyramids also demonstrate a keen understanding of materials. The builders used different types of stone from various locations, each chosen for particular reasons. Limestone, with its reflective properties, reflects light intensely, making the pyramid shine under the desert sun. Granite, used within the king's chamber, is denser and harder. The specific use of these materials indicates not only aesthetic consideration, but practical knowledge of their physical properties. Perhaps one of the most compelling questions is whether ancient builders had insights into energy that have not survived through written records. A small community of researchers speculate that the pyramid designs might represent a lost understanding of electromagnetic forces. Some formations within the pyramids allow for unique energy distributions, captured via subtle measurements of electromagnetic fields. However, it's crucial to stress that these findings are in early stages, with much work remaining to draw firm conclusions. The methods the Egyptians used for measuring and calculating their constructions were incredible as well. The precision of angles and dimensions in these massive works of architecture is nothing short of amazing, often with more accuracy than the tools available at the time would suggest. This has led to ongoing studies of their measurement systems, which might have been more advanced than traditionally thought. Ultimately, what we uncover about these ancient wonders represents a blend of scientific exploration, historical curiosity, and cultural appreciation. As archaeologists continue to study these structures and their makers, with newer technology like 3D scanning and ground-penetrating radar, deeper insights seem just over the horizon. Though we've unraveled many threads of how pyramids were built and how people lived in that age, the full knowledge possessed by our ancient ancestors may never be wholly understood. While we may not yet fully comprehend all the forces at play in constructing these monumental achievements, one thing is clear: ancient builders certainly possessed a remarkable ingenuity and understanding of the natural world. Their achievements continue to inspire scientists, engineers, and dreamers alike as we strive to uncover the sophisticated simplicity and hidden complexities of these ancient puzzles. The more we learn, the more we see that, in many respects, while times change, the pursuit of knowledge remains as timeless as ever. Chapter 9. Balance Beyond Measure. Imagine a world where ancient builders had a deeper grasp of the forces around them than we give them credit for. The structures they left behind have withstood the test of time, making us wonder just how they achieved such feats. These architectural wonders, from the pyramids to ancient temples, suggest a level of construction know-how that seems almost magical to us today. Could it be that these builders understood principles of physics that we now struggle to comprehend? Let's start with the basics of balance and weight distribution. These are concepts we often take for granted in modern construction. Yet, the ancient builders seemed to have an intrinsic understanding of such concepts without advanced tools or complicated technology. Consider the Great Pyramid of Giza. For thousands of years, this structure stood as the tallest human-made building on Earth. Its precise alignment with true north, the careful arrangement of its massive stones, and the even distribution of weight all suggest that its creators knew how to manipulate mass and gravity in a sophisticated manner. One of the most intriguing aspects is the materials used. Limestone and granite, chosen for their durability and availability, also have specific densities that help distribute weight evenly. Could ancient builders have known about material properties in ways that align with modern understanding? Scientists today use similar principles when selecting materials for construction, knowing how different densities can affect a structure's stability. These builders also mastered the art of withstanding natural disasters. Earthquakes, a constant threat to ancient civilizations, led to the development of buildings designed to endure the Earth's tremors. For instance, take the Parthenon in Athens. It's believed that the Parthenon's subtle curves and the slight incline of its columns were deliberate choices made to enhance stability and resilience. Modern structural engineers have studied these features, noting how these techniques align with ideas of dynamic load distribution, which is about how a structure spreads forces when under pressure or vibration. In this way, the ancients might have anticipated concepts that wouldn't be formally named until much later. Moreover, the builders seemed to understand the importance of geometry, not just in aesthetics, but in function. The precision with which these ancient structures have been executed reveals a meticulous application of geometric principles. If you've ever marveled at how little has shifted in these structures over the centuries, you've witnessed this firsthand. For instance, ancient Roman architecture frequently employed the arch, a shape that naturally redirects weight, distributing it down into the foundation more efficiently than a flat line or angle between columns. Let's not overlook how ancient builders adapted to their environment. They used local materials creatively and aligned structures with celestial bodies, an intersection of astronomy and architecture that captivates historians and scientists alike. Stonehenge, though mysterious, is often cited as an early model of how ancient peoples incorporated knowledge of astronomical cycles into their structures. As we delve into technologies like laser surveys and computer simulations, researchers continue to find that ancient alignments often bear remarkable accuracy. A seamless blend of their environment and engineering possibly gave rise to a kind of ecological balance. Minimizing the impact of these impressive constructions on their natural surroundings, the Incan city of Machu Picchu demonstrates this philosophy beautifully. Built atop the Andes Mountains, this city integrates precisely with its mountainous terrain, using terraces to prevent erosion and clever water management systems to redistribute water flow from their freshwater source. If we dig deeper into the archives, we find beliefs that suggest a profound cultural and spiritual understanding of balance. The concept that everything in nature holds a purpose and is connected informed many of the design choices, implying an intrinsic motivation to maintain harmony in both their lives and architectures. But the most astonishing realization might be the influence these ancient builders have on modern-day engineering. Their techniques continue to inspire the design of earthquake-resistant buildings, sustainable architecture, and urban planning. As we rediscover these methods, there's a growing respect for incorporating ancient wisdom into contemporary practices. So, as we uncover these stone secrets, we are left to ponder: did these ancient builders possess a forgotten understanding of physics, something inherently intuitive or passed down through generations? What if these practices were lost, not because they were primitive, but because they were advanced in ways that modern technology is only beginning to appreciate? If we keep our minds open to learning from the past, then, just like the enduring structures of old, our future constructions might build on this robust foundation of harmony and balance. Chapter 10: Ancient Acoustics. In our exploration of the world's most mysterious structures from long ago, there is a subtle, almost forgotten aspect that deserves our attention, and it has everything to do with sound. Imagine being in a grand cathedral or a vast ancient amphitheater and feeling the sound wrap around you like a warm blanket, or how a whisper can travel from one end of an ancient hall to another with uncanny clarity. This isn't just architectural coincidence. It's a glimpse into an ancient science that might have been far more advanced than we give it credit for centuries before the era of electronic amplification and sound systems. Builders and architects were deeply concerned with how sound moved and how it could be enhanced naturally. Let's wander back to ancient Greece, home to some of the earliest theatres we know. The theatre at Epidaurus is famed not just for its beauty, but for its remarkable acoustical properties. An actor standing at the center of the circular stage can speak in a normal tone and be heard clearly by someone sitting at the top of the tiered stone seats. But how was this possible? Studies suggest that this auditory marvel isn't merely due to a stroke of architectural luck. Researchers have examined this ancient theatre and pointed out that its design seems to suppress low-frequency background noise, which helps carry the human voice farther. The limestone seats also play a role in reflecting sound waves effectively. Acoustical engineering, it seems, was alive and well long before we gave the field a name. Looking further east, we find the ancient city of Palmyra in present-day Syria. Here once stood the great temple of Bel, a site with its own acoustic wonders. The temple complex could host large crowds, and during rituals or public gatherings, the sound had to touch everyone equally. Experts believe the design involved deliberate placement of walls and openings to let priests' voices carry without much strain. But let's not stop there. Have you ever heard of sound mirrors? Before radar was developed in the early 20th century, countries like Britain built large concrete walls and discs at strategic coastal locations intended to reflect sound waves from approaching enemy aircraft. These structures are much more modern, of course, but their underlying principle isn't new. We see echoes of this practice in ancient times in places where natural landscapes were used to bounce sound, such as the rock formations of the ancient Vedic sites in India. The builders seemed to understand naturally occurring acoustics and used these landscapes for religious ceremonies, allowing priests and speakers to be heard over large distances. Moving to the Americas, the Mayan city of Chichen Itza reveals another wonder with its famous pyramid, El Castillo. If you clap your hands in front of the staircase, the echo mimics the chirping of the local sacred bird, the quetzal. Whether this was an intended effect or a happy accident remains a topic of debate. But the presence of intentionality in Mayan architecture cannot be ignored. Structures were often aligned to enhance sound during ceremonial events, ensuring that the voices of priests carried during important rituals. All over the world, there are whispers, if you'll excuse the pun, of a deep and perhaps widely forgotten understanding of sound. The ancient builders seemed to have a profound appreciation for how sound worked and how it could be channeled or enhanced by design. Their works suggest that they possessed an intuitive grasp of auditory physics, blending science and spirituality seamlessly. Questions linger about how far their knowledge went and whether we have merely scraped the surface. Did these ancient architects rely on trial and error, or did they have more structured knowledge that allowed them to predict outcomes reliably? Unfortunately, much of their rationale remains shrouded in mystery, either because records didn't survive or their understanding wasn't encoded into texts as we know them. While modern technology provides us with sophisticated means to manage sound much more precisely, these ancient acoustical spaces teach us an important lesson about the intersection of form, function, and environment. They invite us to explore, to ask questions, and to appreciate the ingenuity of those who came long before us. As we stand in these spaces today, their silence speaks volumes, waiting for us to listen, really listen, and learn anew.